in data science, and welcome to the fifth and final day of our online data week this year. It's been a week packed with speakers and workshops showcasing the latest in data science and AI. So I just wanted to go through a little bit of housekeeping before we launch into the event itself. Please do note that this session is being recorded. And so please ensure that you've had a look at the JGI Code of Conduct for our events. For the comfort of participants, please do mute your microphone unless stated otherwise, or unless you're the chair and attempting to give a presentation. And please do complete the registration and feedback forms. James, who's my colleague at the JGI, is going to be sharing the links for those in the chat box for you to go to. Your feedback's really important for us for knowing how you found the event and planning future events as well. And do feel free to participate by introducing yourself in the chat box. Let us know your name, your role, and where you're coming from. So there will be a Q&A at the end of this presentation, and we invite you to submit questions using Slido. So you can get there by either going to slido.com or scanning this QR code and entering the code 326268. I think James will also be sharing this with you in the chat as we go through the presentation today. And so this week is hosted by the Jean Golding Institute. We are a central hub for data science and data intensive research at the University of Bristol. We're one of 5 university research institutes, and we connect multidisciplinary experts across the university and beyond. So we have several international partners, including the University of Strathmore in Nairobi and the Institute of Statistical Mathematics in Japan, as well as national partners, including, for example, the Alan Turing Institute. We provide events, training, funding opportunities, as well as a data science consultation, advice and support service through our Ask JGI platform. So I just wanted to take a moment to flash up the timetable for this week. Obviously, we are on the 5th and final day, as I already noted, but we do still have lots of exciting events yet to come. I wanted in particular to promote our lunchtime networking event, which will take place on the Remo platform at, I think, 1 o'clock today. So this will be a chance for you to get to meet other people who've been attending sessions throughout the week and network with people across the university, including at the Jane Golding Institute. There's too many for me to mention everyone by name, but obviously this week would not be possible without our partners and sponsors. So I just wanted to flash up this slide so that we could give credit to everybody. We hope that you'll connect with us and keep in touch, so you can keep the conversation going by getting us on Twitter at JGI Bristol, #Bristol Data Week. We also hope that if you'd like to keep up to date with our kind of news and events, you'll consider subscribing to our newsletter. So to do that, please go to our website at bristol.ac.uk/Golding. We also hope that you'll be enticed to get involved in our next big event, which will be in 2022. So this is going to be next February, a big showcase event showcasing the latest interdisciplinary advances in data science and data intensive research. We have the M Shed as our venue, which is a flagship museum and iconic building set in the heart of Bristol's historic harbour side. So obviously we're hoping that this is going to be a family-friendly, open to the public, face-to-face event where we can network, socialise. There'll be inspiring speakers, exhibitions, workshops and performances. So we hope that you'll put that date in your diary and consider joining us. Okay, I'm going to stop sharing at this point so that our speaker, Dave, can prepare to share his screen. So Professor Dave Cliff, he is a Professor of Computer Science at the University of Bristol. He led the design and creation of the Jean Golding Institute and, crucially, the development of the university's suite of engineering-based data science MSc degrees. He's the current director of the MSc Data Science programme. So Dave, without further ado, I'm going to hand over to you if you're ready to begin your presentation.
Sure. I just wondered, can you hear me? Just 1 second.
Loud and clear.
Oh, good. Okay, great. Good. So thank you very much for that introduction. Whoops, I seem to, oh Lord. Let's start again. Here we go. So you came here to see a presentation about the Data Science MSc, but as was just mentioned in that introduction, I'm responsible for a suite of related Master of Science degrees. So the very first one of those was the Data Science MSc. We designed that a couple of years ago and we launched it with our first students this September, just gone, September 2020. So our first cohort of 83 students is right now just starting their MSc projects, and they'll be writing up their theses over the summer and submitting. But this is just the first in a series, and so in October of this year we'll be taking on our first students for the first of our related data science degrees, which is the official title is Financial Technology with Data Science, but we call that Fintech just because that's the word that everyone else uses, and it's only 2 syllables. So what I'm going to do today is I'm going to talk about the Data Science MSc, which is up and running, and then what I'll do is I'll explain the differences between the Fintech MSc and the Data Science MSc. And really that's all I'm here to do. However, in order to kind of motivate the reason why we're running this MSc, I'll also talk about the skills gap both in data science in general and also specifically in fintech. And I'm deliberately going to end quite early so that there's lots of time for questions. The one other thing to say is that right now, the only option for taking either of these 2 MScs is that you register at the university and spend 1 year taking them full time, ideally on campus, as long as there's no more pandemics. However, the Data Science MSc, we're currently in the late stages of getting approval to make it online part-time. And that would mean that you wouldn't have to relocate to Bristol. So that won't be happening this year. That is also something that we're hoping to be able to officially announce for students who would start in October of 2022. So in about 15 months' time. So that's what I'm going to talk about. Here goes. Well, there has been a revolution, and that revolution is often referred to as the big data revolution. And sometimes data scientists are people that come from a mathematics background, and they kind of think, oh, data, analytics, that's what I do. I'm a mathematician. But I'm a computer scientist, and I think actually computer scientists deserve much of the credit for the big data revolution, because very often the mathematics that's done on the data is relatively conventional. But the thing that is unconventional, the thing that's revolutionary, is the fact that technologies have been developed, which means that we can gather vast quantities of data at very, very low costs per bit of data, or per byte of data, or per kilobyte, per megabyte, per terabyte, you choose. But we now can gather huge quantities of data, and then we can route that effectively instantly, because of advances in communications technology, to super powerful computers, which we don't have to own anymore because they're out there in the cloud, and do analysis on that data in close to real time. And that means that it's possible to respond or predict to all sorts of things that matter in the worlds of government or commerce or business or industry or defense or education or health and social care. Pretty much any sphere of human activity has the potential to be greatly improved by the effects, the technologies, the tools and techniques which are being delivered from this big data revolution. So a lot of that actually involves machine learning and artificial intelligence. If you have all this data being gathered and then you just need lots of humans to understand the data, that's a really, really expensive way of doing things, because quite rightly, human labor is not cheap. However, if you can make a machine which does what that human does, even if that human would normally be described as intelligent for doing that thing, if you can make an artificially intelligent entity that does that thing, then the costs can be greatly reduced, and that lowers barriers to entry and enables applications to be delivered that would not otherwise be affordable. So I see data engineering, the gathering of data, the kind of piping, the processing, the analytics, and the machine learning and the AI all as part of data science. And this has huge value to organizations of all different scales. And if we look at the two ends of the scale, if you're a small 2-person or perhaps 2-person and a cat startup just working in a garage somewhere because you can't yet afford office space, It used to be that if you wanted to gather large quantities of data and do really advanced processing on it, you would need a very large budget for data storage and for compute, for computational power to analyze that data. With the rise of cloud computing, that's pretty much disappeared. Now, as long as you've got a clean credit card and a web browser, you can assemble in the cloud web services which will gather that data and process that data. And so this gives you, as a two-person startup, the same compute and data analytics processing capability that would normally be associated with a massive global multinational. However, if you are a massive global multinational company, 200,000 people or more as your employees, then very often what you find is that it's quite difficult to know what's going on because there is so much going on. And for that reason, it's quite difficult to react responsively as your world changes, to be agile. Agility is usually associated with very small companies, not with very big companies. But again, there are various ways in which machine learning, AI, big data, data analytics can greatly increase the agility of a very large corporation and allow it to act in real time or very close to real time as important changes happen in its operating environment. Let me get to the next slide. So, well, I've got ahead of myself a little bit there because I've mentioned this several times already. So much of this can be done via remotely accessed services, which is a long way of saying in the cloud. There are companies like Amazon Web Services, which is the market leader, AWS. Other companies like Google Cloud Platform, Microsoft Azure, Oracle also have a cloud. Most IT companies now many IT companies now use cloud services. If you've ever used Dropbox or Netflix, that's actually running on Amazon's cloud, AWS, or at least that's where those businesses started. And despite having said all the good things, we need to remind ourselves that some bad things could result from careless or perhaps willfully malign applications of data science. So any data science practitioner needs to be familiar with ethical and political and legal and social and economic aspects of what they're doing. At the base level, if you're dealing with data, then in the EU, you need to be mindful of the GDPR regulations. And 3 or 4 years ago, there was this scandal about a company called Cambridge Analytica, who had, in a fairly sneaky way, harvested an awful lot of data from an awful lot of Facebook users and were then being paid to send very, very finely resolved political advertising to particular individuals in order to who had been selected as being likely to change their vote in places where there was a very small swing required in order for the vote to change. And this gave rise to serious concerns about whether election law is still appropriate to the kind of technologies that people can now deploy when they're trying to get elected. So there are issues of, do the laws need changing, because some things might be happening that are not strictly illegal, but nevertheless look to be morally questionable. And in most liberal democracies, the maintenance of free and fair elections is a cornerstone of that democracy. And if democratic processes are being distorted by the application of big data techniques, then the populace, the society, should have a view on that and perhaps act to change it. So all of these are the kind of things that we look at in our Data Science MSc. It's a 1-year MSc. It's at the moment it's studied full-time. In a couple of years' time, you'll be able to do it part-time online over 2 or 3 years. We hope. It's not officially announced yet. But one of the, when people say, well, why should I study data science? One of the best motivations is reading this report, which came out in 2019, so it's a couple of years old now, and it came from the Royal Society, which is the world's oldest and many would argue most respected learned society for world-leading scientists. And they did an analysis of UK demand for data science skills, and they had found over the period 2014 to 2019, so in the 5 years leading up to this report being published, demand for data science skills, so jobs that said you need to be a data scientist, we need a data scientist, or that requested or specified skills which are clearly within the data science realm, they had risen by 230% over that 5-year period, whereas other science, technology, engineering, mathematics, medicine type of job applications, demand for other STEM skills had only risen 30% over the same period. But clearly, this is the best part of 7 times more increase in demand for data science than there was for other STEM subjects. They found that there were over 27,000 data science specific job adverts in the 1 year leading up to the publication of their report. That's quite a lot of jobs. And they also found that the average salary for those jobs was in excess of £64,000. Whoops. Bear in mind that the median salary in the UK is around about £31,000. So you can earn twice median salary by becoming a data scientist, on average, in principle. So we recognise that very many of the people that study on our Data Science MSc and also on our Fintech MSc are doing it with the definite intention that when they graduate at the end of their 1 year master's degree, they will go out and get a job. So we work very closely. We're a big faculty of engineering. We have lots of partners in industry, and in the design and in the delivery of these programs, we've worked closely with our partners and friends in industry to ensure that what we're teaching is not some kind of blue sky, ivory towered academic version of data science, but is very, very close to what our employers are looking for right now. And we're in a constant process of revising the MSc curriculum for that reason. If we move to FinTech, very recently in February this year, there was the Khalifa report, which was commissioned by the Chancellor of the Exchequer. It established that something that many people already believe to be true, which is that the UK is a global leader in FinTech, and that by 2030, so within the next 8 years or less, roughly $14 billion is estimated to be contributed to the UK economy by FinTech organisations that are operating in the UK. But the challenge to delivering that contribution is access to suitable, skilled and talented people. Many people might have talents, but if they don't have the skills, they can't apply their talents. And 67%, so 2/3 of UK FinTech companies consider talent acquisition, so hiring people and retention, to be their highest priority. And basically there is a talent gap, there is a skills gap, which we see our education in the Faculty of Engineering as being directly intended to address. Other statistics from the Khalifa report: 43% of job adverts from UK fintech scale-ups were seeking data skills, and 44% were seeking technology skills, so perhaps cloud computing or AI and machine learning. Expertise in AI, in data and machine learning are all reported only 3 months ago, to have been in very short supply. And I mean, for any of you who are watching this remotely thinking, would I like to study in Bristol? Yes, do. Bristol is a fantastic city to live in. I've lived here for 20 years. It's a fantastic place to be a student in. We are a fantastic university. Our faculty is a fantastic faculty. And these 2 degrees are fantastic. But furthermore, the Bristol region has been recognised as a very fast-growing hub for fintech. It's long been recognised that Bristol and Bath, taken together as a cluster, is a nationally leading digital technology hub or cluster, but Bristol in particular concentrates on fintech, and it's now part of the West of England Combined Authority. So we have a regional mayor for our bit of West England, and fintech is on the industrial strategy, one of only 3 or 4 topics for the WECA industrial strategy, West of England Combined Authority. So if you come here to study, the chances are you'll be, when you go to graduate and you go to find a job, the chances are there will be some job opportunities in the Bristol region, Bristol City or surrounding. So let me tell you about the structure of the degree. It's like many 1-year degrees, it's divided into 3 phases. And in Bristol, we use bizarre language. We call our semesters, our terms, teaching blocks. So we have teaching block 1, but I'm actually on this slide, I'm just going to call it semester 1. That runs for 4 months, from October to January. And then semester 2 runs from February, March, April, May. So that's another 4 months. And then in June to September, people have the summer period, which is also sometimes referred to as teaching block 3, semester 3. And as with many MScs, the way we've structured this is that in semester 1 and semester 2, you'll do taught units. So you'll be attending lectures, doing lab classes, doing problem sheets, doing independent study, doing assessments, exercises, and so on a range of topics, and I'll tell you what those range of topics are. And all of that equips you with sufficient skills that when you come to do your summer work, you can do your individual project. You'll spend about 600 hours on it, and you will write up an MSc thesis, maybe 40 pages, maybe 50 pages, maybe 60 pages. And that's just you writing about work that you have done. And because we at Bristol are a research intensive university, because everyone who teaches on this MSc has a really strong background as a researcher in relevant fields, very often your individual project will be something that's either at or really close to the leading edge of data science or AI or ML, machine learning. And we have a strong track record of taking people that have done master's theses and turning their theses, often co-authoring with their supervisor, into a peer-reviewed scientific publication at an international conference or an international journal. Sometimes it's just the supervisor with one student, sometimes it might be two supervisors with 4 or 5 students where they've each contributed something to make a paper. But one reason for coming to a research-intensive university like Bristol is so that you can be exposed to the absolute leading edge stuff. Much of what we teach, there is no textbook, because textbooks tend to get written 5 or 6 years after new developments have occurred. So textbooks are a slow form of learning. They talk about stuff that's been true for a long time, but if you want the leading edge, you're going to be working from research papers. So quite a lot of the assessment that we give people involves them reading research papers and writing things which have the look and feel of a published research paper. So that's the individual project. I think of that as kind of, we spend semester 1 and semester 2 teaching you how to fly, and then in the summer you do your solo aerobatics demonstration. It's where you're showing us all the things that you've learned, but also very often you'll be doing stuff that's working on a problem which has been specified or suggested by one of our industrial partners. So it'll be real world relevant, and that's a really useful calling card to have when you're trying to get a job. You can talk about the fact that you used leading edge techniques on a real world problem and you delivered an MSc thesis and maybe also a publication. So let's go right back to the beginning of the year and look at what we teach. So we take students from a wide range of backgrounds. You don't have to be a mathematician or a computer scientist or a software engineer in order to study on this degree. Right now we have economists, we have people that have done business studies, we've got chemical engineers, we've got a theoretical physicist, we've got an astrophysicist. We do have a fair number of computer scientists and software engineering people, but they're actually only about 40% of the total intake in this year. So for students who don't have a background in computer science or software engineering, we have a unit. By the way, all the units that I'm going to talk about have a 4-letter acronym, just because it's an awful lot quicker. So we have a unit which we call SDPA, which is Software Development, Programming and Algorithms. And that's going to take you about 200 hours, so that's 20 credit points. You need 180 credit points to get an MSc from any UK university. So 20 credit points on basically how to write Python, how to do software control using GitHub, how to look at an algorithm and say, well, maybe that's going to run really slow, and maybe there's a different way of organizing that algorithm to make it run much faster. So it's all the stuff that you would have got if you had studied computer science that you would then need for our MSc, but it's compressed into 200 hours of study. So that's if you're not a computer scientist. And the kind of books that we look at there illustrated here. This is not a promise that we will be working from these books if you come to study with us, but actually we did use all 4 of these in this unit in this year. So similarly, I'll be showing other books for other courses, and what you need to know is that they're indicative rather than a binding contractual promise that we'll be working from that book. But yeah, we use O'Reilly books, the ones with the grey images of animals on them, because they tend to be really high quality. And that Python crash course is just a really great book for people that have never programmed in Python, or indeed never programmed at all before. If you do have a background in computer science or software engineering, then you're going to know Python, you're going to know GitHub, you're going to know how to analyze an algorithm. But the chances are, and this is something of a failing in most computer science education, is you probably have never structured an experiment or had to analyze much data. If you studied physics or psychology or chemical engineering, you'd spend every year for your 3 or 4 years of your undergraduate degree generating data, analysing it, cleaning it, wrangling it, plotting it, visualizing it, and drawing conclusions from it. But computer science and software engineering just don't really do that. So if you do come to us with a CS or software engineering background, we put you through a different unit, not SDPA. You go through SCEM, which is Statistical Computing and Empirical Methods. It teaches you how to design an experiment, how to gather data, how to process it using the specialized statistical language called R, the letter R, which is a programming language. And that means that you get the kind of empirical methods, experiment design, and statistical analysis skills that you missed out on because you didn't study physics or psychology or chemical engineering. And that currently, that's the only choice point. So we take in students from all sorts of backgrounds. Roughly this year, roughly 60% of them did SDPA, roughly 40% of them did SCEM, and then from that point onwards, everyone does the same units. So, there's the picture of some of the books that we used this year in SCEM. So we teach R and we teach about design of experiments. So that's one unit. That's 20 credits, but you need 60 credits to finish semester one. The next unit that we do, all students take this. The title is LSDE, Large Scale Data Engineering. That also is 20 credits, so that's also supposed to take about 200 hours. And if we wanted to give it a different name, we might just have called it Cloud Computing, because what we teach in LSDE is pretty much everything you need to know to be a bona fide cloud computing engineer or developer. So we teach about Spark, which is the kind of leading edge equivalent of an old technology called MapReduce, which is what Google built their data centers on, the software that goes into Google's data centers, I should say. We look briefly at how data centers are designed and built and cooled, because cooling is very important. We look at this astonishing open source collection of software packages called Hadoop, which can do pretty much anything that you might want to do in the cloud, but the software is open source, so you can analyze the software, you can edit it and use your own versions. And we look at more general issues about architecting modern data platforms. It just so happens that my colleague Alan Forsyth, who teaches this unit, prior to joining the university was qualified, he had the highest level of qualification for training people in Amazon's AWS Web Services certification. So in fact, we set the syllabus of this unit to be so close to the AWS certification that students who have finished this unit can then go off to AWS and take the certification exams and have the entry-level AWS certification as a cloud engineer. And that I think is just an indication that, you know, we really do, we're an engineering faculty and we take data engineering just as seriously as we take data analytics or data science. And then the final unit that you have in semester one goes by the name of TIBBS. This stands for Technology, Innovation, Business and Society. Actually, as part of Data Week on Monday, I gave a whole lecture about the reading list on TIBBS because it's 50 books and I can't show you 50 books on these slides, but the kind of things we look at are the legal aspects, so intellectual property law and GDPR, how to do technology innovation, because when we produce graduates from our MSc, we want them not just to know how to apply existing techniques, but also for them to be skilled in the mechanisms required to innovate, to create brand new techniques, and furthermore, to commercialize those innovations. We expect a fair number of our students to go off and get jobs with existing companies, but we also positively encourage our students to start their own companies and to be entrepreneurial. And part of the TIBBS unit talks about how to start a company, how to find funding, what the legal issues are, what the process of how best to organize the process of innovation in a technology innovation company, but also looks at some of the bad sides. So Shoshana Zuboff's book, The Age of Surveillance Capitalism, is an argument against the rise of big data companies like Facebook or Google, who essentially monetize the data that they gather from their customers by offering the customers a free service like Gmail or like Facebook Messenger. And she argues that there are some injustices and there are some things wrong with the way society is heading in its increased reliance on companies that are making huge amounts of money from essentially big data that is gathered from their customers. Shoshana Zuboff is not the only voice raised in concern. So Cathy O'Neill's book, Weapons of Math Destruction, also looks at how data science can be used to reinforce existing biases and, if you're not careful, can increase injustices. Data science is a kind of a neutral tool. It can be used for good, but it can also be used for bad. And sometimes it can be used for bad deliberately, but some of the most pernicious ill uses of data science are where it was just used carelessly. And so in this unit, we try to expose our students to the ethical, the legal, the moral, the societal, the political aspects of data science. And this is something that our industry partners absolutely encouraged us to do. So some of our students kind of arrive and think, right, I just wanted to be a data scientist. I just wanted to do maths. Why am I reading about the socioeconomic effects of data science? And it's because we think you're not a proper data scientist if you don't have a view on those topics. And so you need a view on those topics, and you get that. We don't tell you what to think. We don't tell you your opinion, but we expose you to these ideas, and we give you a lot of opportunity for discussion. A lot of the teaching on that particular unit is seminar discussion based, and you know, everyone has a view, and you know, most views are allowed. Well, all views are. I should start again. Yeah, we encourage people to express their own opinion and to be respectful of other people's opinions, but at the same time, you know, if we have to recognise that some activities that we deal with in the literature that we read are describing you know, deeply undesirable behaviours. There we go. Okay, so that's term one. We do 3 units, each of 20 credits, each about 200 hours. Then in semester 2, we have a 10 credit unit, which is a very kind of breadth rather than depth introduction to all of artificial intelligence. So that's intro to AI, and the kind of books we work from there are the classic Russell and Norvig Artificial Intelligence, A Modern Approach, which is now in its 3rd or maybe even 4th edition. There's a 3rd edition there, but that's been going 20 plus years. The next book, Machine Learning, is fantastic, published by Cambridge University Press, which is one of the best university presses in the world, and it was written by Professor Peter Flack, who's one of my colleagues, one of our colleagues. So his office is opposite my office in the computer science building. We look at modern toolkits like Scikit or Keras or TensorFlow, and we look at the underlying mathematics, so you know, predictive data analytics. So all of that gets covered in that unit, which is only 100 hours, only 10 credits. Then we have a kind of introductory data analytics unit, which we call DAN, just because we needed a 4-letter acronym. That only takes up 10 hours. And the reason why we structure it like this will become clearer when we switch to the Fintech MSc, which I'll come on to in just a bit. So in that, we look at things like how to analyze text, how to understand written paragraphs of text, or how to understand speech, and then also how to visualize data using a variety of methods. And then in the data science, in the pure, what we call the vanilla data science MSc, you then go into all the topics that you've just covered for another 200 hours in an advanced data analytics unit, which again looks at things like understanding news reports and more issues in the visual display of data and in doing data analytics, which very often takes you right into deep into machine learning and statistical AI. And then the final thing that you do before you start your summer project is a group project. This year the students were divided into teams of 3 or 4, and we had 3 industry partners. One industry partner was a biotech company, a startup from Oxford that's doing mRNA gene sequencing. Another of our industry partners, the second, was HSBC Investment Bank, who are based in Canary Wharf in central London. And the third was Lloyds Retail Bank, Lloyds Banking Group, who actually have their data science group based here in Bristol, down on the harbour side. So we had 3 industrial partners. We gave each of them 9 teams to work with, 9 of our student teams to work with, where each team was 3 or 4 students. And the partners said, okay, here's a problem, here's some data. So much data that you couldn't load it into a single PC. It would crash Excel. They were given huge amounts of data. And then they were essentially told, go away and do cool stuff and come back to us, kind of Dragon's Den style, come back to us and pitch at the end of the project, tell us what you've done. Both give an oral presentation and give a written presentation, which should look and feel like a peer-reviewed paper. Our students did absolutely fantastic work on that. It was really energizing to watch them get their teeth into data for the first time. It was also quite scary for many of them. Suddenly they realized the scale of the kind of problems that you work on in industry. But we think that's the best way of teaching people, is to expose them to real world problems and to try and get them to come up with real world solutions. So that is the structure of the Data Science MSc. And the reason why we've structured it like that is because it it can then share many components of this structure with its related kind of daughter degrees, other degrees in the same family. The Fintech MSc is the first of those, and in the Fintech MSc, we take out the Technology, Innovation, Business and Society unit, the TIBBS unit. Some of that content gets woven into the Introduction to Financial Technology unit, INFT, and all the examples and all the exercises and all the assessments in the SDPA and the SCEM unit and the LSD unit are for students on the data science for students on the Fintech MSc are Fintech specific. So if you're doing the data science MSc, you might be in the LSDE, the cloud computing unit, and the exercise that you're being given is use cloud computing to do analysis of insurance data. Oh no, that's kind of financial. Let me think of a different example. Analysis of data from a particle collider, like the Large Hadron Collider at CERN. So some physics experiments. However, if you're on the Fintech MSc, you're guaranteed that the examples you'll be given in each of the units will be Fintech specific. So on the Fintech MSc, you might get some retail insurance data because we have a partnership with LV, Liverpool Victoria Insurance. Anyhow, on the Fintech, the Introduction to Fintech unit, we look at algorithmic trading, we look at financial exchanges, we look at experimental economics, and we also start to look at distributed ledger technologies, blockchain, which underwrites cryptocurrencies, but also have lots of applications in other areas of business and commerce. So that's the first thing that is totally specialized, only taken by Fintech students. In semester 2, the advanced data analytics is now replaced by advanced financial technology. So you still get your introduction to AI and your data analytics introduction in those 2 10-credit units, but now you spend 200 hours doing advanced financial technology. And what that looks at is things like portfolio management, using machine learning in finance, doing time series analysis, like financial time series data have long been studied, and there are lots of methods that you really need to know. And also we look at the outer limits, the leading edge of what's happening in current fintech practice. So that means that by the end of semester 2, you've taken 200 hours in semester 1 and 200 hours, so a total of 400 hours that is specializing you to the world of fintech. However, that's not the only innovation or the only difference in semester 2. The other thing we do is we set you a financial technology group project. So again, the idea may well come from an industry partner, but you're guaranteed that it'll be working on fintech. And in fact, we've written into the first year that it's going to be on looking at smart contracts, so technologies like Ethereum or Solidity. And you're going to be doing that using methods, software engineering or software development methods, which are current in industry. So so-called agile methods and Scrum are also going to be skills that you will learn when you do that group project. And then as with the original Data Science MSc, you then spend the summer doing an individual project and then write a thesis of maybe 60 pages and hopefully get a publication. So that's as much as I had to say, really. I'm the program director for the MSc in Data Science, which keeps me busy but happy. And then my good colleague, John Cartledge, is the program director for the Fintech MSc. John is actually sponsored by Refinitiv. They used to be called Thomson Reuters. So they're one of our strategic partners in this. We have multiple strategic partners, but it's been great fun doing the teaching in this degree for the first year, and it's been great fun telling you, and I think now I am done. Yeah. Oh, well, the only other thing to say is that you're not just there to learn, you're there to have a life. So there's lots of support mechanisms in place at the university, but none of these are specific to the Data Science MSc. They're support mechanisms which are provided for all students, but we take our students' mental health and well-being extremely seriously. And so I'm continually emailing our gaggle of students and saying, remember, you can do this working a 40-hour week. If you work 5 days, 8 hours each day, you should be able to get the highest possible grade of MSc. And it's really important to have a life as well as to study, because if all you ever do is study, you don't have much of a life, and you'll burn out and bad things can happen. And Bristol is such a fantastic place to have a life in, because there's fantastic food scene, music scene, scenery, so much going on. So if you're watching this because you're thinking of coming to Bristol, please apply. And that, I think, is the end of my talk. Yeah. Any questions? I'll end the slideshow there.
Thank you, Dave. Thanks so much for this wonderful presentation, and also for finishing it there, I think, on a really important message that's very timely for the times that we live in. So that was a really enjoyable presentation. We do have some questions that we've collected from participants on Slido. So if it's all right with you, Dave, I'll put a couple of those to you.
Sure. We'll have a cup of tea.
Sounds like a well-earned one indeed. Okay, so one of the questions that we have is about kind of the degree course in terms of what the prerequisites for studying the MSc in data science is.
I think if you go to our website, you'll find what it says is we want you to have a good degree in a STEM subject. So by good, really, we mean 2-1 or a first. By STEM, we mean science, technology, engineering, mathematics, medicine. I think if your undergraduate degree was medieval French poetry, it would be too much to ask for you to come up to speed from a standing start, from not having had any prior background. So the reason why we ask for STEM background is most STEM degrees, well, in fact, pretty much all STEM degrees require basic levels of numeracy, and also most expose people to some kind of coding or programming somewhere through the degree. However, every now and again I get sent an application to make an individual judgment on where, say someone did study medieval French poetry, but then they've worked for 10 years in the software industry. They probably picked up lots of skills through that work experience, and we can accommodate for that kind of thing. But yeah, the basic answer is a good STEM degree.
Thanks, Dave. We have another question here that begins with, thanks, Dave. The MSc course looks very appealing for someone looking to enhance their professional tech career. But is there also a research training component?
Yeah, well, so the group project is kind of like doing R&D, and then the individual project, you have a lot of choice. You could, if you wanted to, you could address something that's essentially pure research, maybe doesn't really have any direct application. So it's kind of a theoretical study, or developing something that's quite abstract, and where any potential deployments in industry or business might be many years into the future. Or you could do something that's really, really concentrated on a current real world problem, and where in principle you could deploy it or sell it the day after you finish. So yeah, if your interest is in developing research skills, then opportunities arise across the year in order to gain basic research skills, in terms of like how to write a paper or how to structure a research program. Actually, we ask all our students to do that on the MSc. But yeah, if you wanted to, essentially, I think 3 of our current 80 students are currently in the process of going off to do a PhD. So our MSc is not only for people who want to go into the world of work, it does also prepare people very nicely for further study in a research career. And the obvious next step would be to do a PhD.
Thanks, Dave. And maybe kind of leading on from that, we've got a question from Martin asking whether the courses are applicable for mature students looking for skill enhancement.
Oh yeah, absolutely. I actually genuinely don't know the statistics, but from interacting with our students, I would say a good third of them look to me like they're in their 30s. And a couple of them look like they're probably in their 40s or older. So yeah, no, we welcome mature students. We like people who've got experience. We value that.
And approximately how many people did you have on the course this year?
This year we started with about 87, and a few people, and this happens on all degrees, so don't take this badly, but yeah, 2 or 3 people left within the first 2 or 3 weeks. Some people actually started believing that they would have some funding, and then they had problems with their funding. But the other statistic to know is the number of applicants was over 1,500, and I think this year I think we got close to 2,000 applicants this year. So it is very competitive to get in, and it does fill up very quickly. So to a first approximation, admissions are done first come, first served.
Wow, high demand.
Yeah, massive. Yeah,
massive. Okay, so then there's just a couple on course content again, I think. So the first one is about how quality control and validation of data is a really important part of data science projects. So is there dedicated training for this part of the data science pipeline included in the MSc programme?
Yep, we cover kind of data cleaning, data wrangling, quality assurance. The students who worked on the project that was specified by HSBC Investment Bank were given a bunch of data, and that data happened to have some corrupt data in it, which is what happens in the real world. So they learned quite a lot about dealing with imperfect data there. So it's something it would be remiss of us not to cover.
Absolutely, thank you. And I think this is the final question, unless anybody wants to put some last minute additions in there. So does the MSc course have presentation components that help budding data scientists develop their communication and information dissemination skills? So you've already mentioned, I think, some of the project work, which might be relevant to that question.
Yep, it certainly does. So both in the group project and in the main project, a sizable part of the actual assessment is on the basis of a presentation that you give about your work. I should have all the statistics on the top of my head, and I don't. But I think for the final project, you submit an initial plan and an initial literature review round about now, and then in September you submit your dissertation and you give a presentation. And I think that presentation is worth 15% of the overall marks, maybe actually 25% of the overall marks. So the ability to present is vital. The ability to communicate is vital. But we communicate not only by speaking, but also by writing, and sometimes in visual means as well. So all of that is something that we use in our evaluation, in our assessment of how students are getting on. Many students will come from backgrounds where they haven't necessarily done a lot of writing, and there is most of the assessment this year, partially because of COVID measures, it was easier to assess by coursework than by exam, and so we asked people to write me an 8-page paper on this pair of books, or write an 8-page conference paper that describes what you did for your programming project, that kind of thing. And we think presentation is an essential transferable skill. And in fact, we also ran non-assessed, optional, additional face-to-face activities when the lockdown restrictions allowed us to have people on campus. So I did a whole session, a 3-hour session on how to write a paper, which is basically how to tell a story. If your paper doesn't tell a story, no one wants to read it.
Thanks, Dave. Yeah, that's really interesting as well, because I challenged people to submit last-minute questions, and of course they did. So there is actually a question.
I was waffling to try and fill the space.
Oh, sorry. Well, so I think you've kind of already answered one of them, which is indeed about kind of technical writing and support available for technical writing, and indeed how much the practical assessment is technical writing or kind of workshop based.
I don't really know what workshop-based would mean, but yeah, we ask people to write, and we ask people to write reasonably clearly so that we can understand what they're doing. But this isn't a creative writing degree, so and we take many students from where English is not their first language. Many of our students come from overseas, which is fantastic, and it's great that we have such a vibrant international community of students who can draw on lots of different cultural backgrounds. But yeah, so what we say is, it's the message of the paper that matters, not necessarily the finesse with which your finely crafted English is written. But we do also point people at various. There's a document that I give all the students, which is my own hints and tips on writing. It's just common problems that I've seen every year because I've been doing this job for a long time. But I used to work at MIT. I used to co-teach with my colleague Patrick Winston, who sadly died a couple of years ago. But Patrick was a genius communicator, and luckily before he died, I don't know, maybe 10 years ago, he gave a 1.5-hour lecture that's on YouTube, and so we go through that lecture with Patrick talking about how to present, and he was one of the best people on the planet to tell people how to present. And we have lots of resources. It's not all self-generated. Steve Pinker has a really good online video as well, but we work through those with the students. So yes, is the short answer.
Thanks, Dave. So I will stop the questions there. I think everybody found this a really helpful and informative session.
You're welcome. Thank you for listening.
So yeah, I just again like to say thank you. I'd like to encourage everybody who attended to please fill out the feedback form, which I think my colleague James has posted in the chat below. It won't take long, it's super quick, and we would really appreciate your feedback on this event. There are other events later on today, and I think James will post the link to some of the next ones in the chat as well. We'd like to promote in particular our lunchtime networking event, which will take place on the Remo platform at 1 o'clock. And that'll be a chance for you to get to meet with some of the speakers and some of us. So please do feel free to come along. And I think that's everything from me. So yeah, just again, thanks very much, Dave. And it was an excellent talk. We really enjoyed it.
Thanks very much. I'll say goodbye. Cheers. Bye.
Bye, everyone.